All right, good afternoon, everyone. I'm Vicky. I'm the lead at DSC at UW. Today, we have invited Mrs.Margaret Maynard-Reid for AI for Art and Design with TensorFlow Lite. Let's welcome her, and while we're waiting for other people, just welcome Miss Margaret.
Hello, Vicky. Thank you for inviting me. And hello, everyone. I'm very excited to be here to talk about AI for art and design with TensorFlow Lite today. So I'm a machine learning engineer and artist working on how to apply AI to art and design. I lead GDG Seattle Data Analytics and Machine Learning, and my area of expertise is computer vision, in particular how to implement deep learning models on Android with TensorFlow Lite. Previously, I worked on the Microsoft Design Studio ML Labs team, and also the Microsoft AI Research Computer Vision team. I have also taught Android at UW Continuing Education a few years ago. I really enjoy art and design and have been spending a lot of time drawing and painting every day. So here is a link to my online gallery where you can check out my artwork. So today I'm going to go over first how to use AI for art and design, some general computer vision tasks and generative art and design, and then share with you some resources. Then I will give you an overview of TensorFlow Lite, then share with you some samples and tutorials made by the TensorFlow Lite team and also the community, including some of the fun projects that I worked on. So AI and design is really a broad topic with lots of different subfields. So today, in my talk, I will discuss just some of them. So what is computer vision? And computer vision can have different tasks, and it helps the computers see the images and to perform one particular task. For example, you can classify an image belongs to a class. Is this painting? What is the style? Who's the artist? Or you can classify an image to multiple classes. For example, for this movie poster, you can figure out its action and its sci-fi. And then we can use feature extraction to extract latent features of an image with CNN models and to perform visual search. So given a query image, you can find like similar images similar to that query image. We can do object detection to identify one or multiple objects with these bounding boxes. And then there's segmentation, where you classify whether each pixel of the image belongs to a certain class. So there's also generative models, where you have two or more models trained simultaneously, and you can generate new images or apply super res to improve the resolution or perform image-to-image translation, like style transfer or create artistic images. So now I'm going to talk about generative art and design. Deep Dream in 2015 that visualizes patterns learned by a neural network. This was perhaps one of the earliest examples of using AI to create art. So, and then there's style transfer from 2015. It uses the CNN neural network to apply the style from an style image to the content image, and then you ended up have a combined image, which is slightly different from how GANs work. And later on, I will show you some other examples. So the style transfer simply just like combine these two images. And I have included a link here for you. Like there's a blog post someone written, an engineer written, called the Neural Style Transfer 50 Sheets of Mail. And this is an example where an engineer can generate these really artistic images using style transfer. So generative adversarial networks in 2014 was created by Ian Goodfellow, and GANs has a lot of different variations, and but each GAN architecture has at least 2 network models which compete against each other. A generator that does the generation of the images, and then a discriminator kind of assess whether the images that generated are good or not. GANs are really fun, but difficult to train. I have included all these links here. There's a lot of GAN variations, but I included this original paper, and then I have also included the DC GAN. This is like really the simplest one if you want to start with the like a tutorial GAN tutorial. You start with DC GAN, and then there's like conditional GAN, and then we have pix-to-pix, CycleGAN, style GAN, many other variations. So pix-to-pix 2016 was introduced to convert. It was able to convert black and white images to color images, as you can see all these examples here. I have included a TensorFlow tutorial here for you to check it out. And notice that all these training images are paired. That they're exactly the same, except that they have a different kind of a style. One is a day, another is a night. This one is just sketches, and another one is more like a photo finish. And then black and white to color, but they are paired training images. And 2017 CycleGAN was introduced, and notice that this, the training data actually are not paired. Like for example, you can just feed in a bunch of training images of oranges and a bunch of training images of apples, but they don't have to be like this one-to-one translation in the training data. However, they output, the model that you can apply that model to a horse and turn it into a zebra, or vice versa, right? And then you can turn like photos into famous paintings. I have also included the link here for you, the TensorFlow Lite, TensorFlow tutorial. And then in 2018, Google researchers experimented with Big GAN, which is a large-scale GAN that generates high-fidelity class conditioned image. And again, I have included links here for you to the paper. And here you can actually go to TensorFlow Hub and download these models. And then you can, in here, I think you can also play with the Colab notebooks as well. In one of the main challenges with GANs is that you don't have a whole lot of control over the images that are generated. So in 2018, NVIDIA research created CycleGAN that allows you to have more fine control of the generated images. Like for example, all this face is generated. You can kind of control the pose, the face shape, age, gender, and hair color, etc. In your image generation. And then later on, there's also CycleGAN too. Now, I want to talk about another example. In 2018, Microsoft AI Lab created Sketch-to-Code, which is a web-based solution that uses AI to transform like a handwritten user interface from a picture to a valid HTML markup code. To train machine learning models, you will need a lot of data. And there are not a whole lot of, in terms of the images, you can find a lot of photos, a lot of training images that are photos, but there are not a whole lot of art images that are already ready-made for machine learning training, and also not a whole lot for UI and UX design. So I have included here for you, some of which I believe like this are images, drawing, painting, sculpture, and engravings from like Kaggle, Overwatch Hero recognition. These are ready for your machine learning training. But a lot of the museums, like they have released free images. Art Institute of Chicago, Museum of Modern Art Collection, etc., etc. I have also included on my GitHub, Awesome AI and Art Design, a couple of other links to other museum where you can find images, free images, like from the British Museum, just several museums, quite a few museums give these free images. However, you will need to get the images and them and pre-process them for training. When we talk about AI for art, the first thing comes to mind, in terms of projects, it's probably Magenta. So has any of you heard about Magenta? Yeah. So check that out if you haven't. It's a open source research project that somebody said no. Okay, good that I'm mentioning that in my talk then. So it's open source research project uses machine learning to make music and art. It's an initiative by Google, but it's an open source project. Anybody can contribute. Yeah, sure. Please check it out. There are lots of cool demos. And there's this website called the Artists and the Machine Intelligence, which is a program at Google that brings artists and engineers together to realize projects using machine intelligence. And you can read about, it's not just painting, but artists include like musicians, right? How they make cool music or use AI to help them in their music production. And if you're interested in using AI and machine learning with UX design, you should check out this AI and the future of UX. I have included a link here for you. It has a lot of cool blog posts, collection of blog posts on AI, what the impact is and how it will shape and influence the future of UX. So we are really living in very exciting times. If you are an artist or designer, AI can help assist and inspire you. And if you're not an artist or designer, you can still make art and design with the help of AI. So now let's look at how we can use AI machine learning with art and design. In particular, how do we use TensorFlow Lite to create applications to perform some of these tasks and examples I mentioned earlier. So are all of you familiar with machine learning or no? Isn't the concept of machine learning new to you? Yes, no? Okay, familiar with machine learning. Who here is not kind of familiar? Okay, good. So the reason why I included this slide is for those people who are not familiar with machine learning is what is a model, Before this whole machine learning thing, I'm thinking about a model, some sort of fashionable clothes. Well, machine learning models actually, deep learning models are actually a very complex mathematical function. It's a representation of learning from training data. Deep learning models, sometimes you can think of it some sort of like magic wand or sometimes kind of black box. Although these days there's a lot of initiative on explainable AI to try to explain the process of model training, how the model makes the decision, etc., etc. So here is the model training conversion inference pipeline. First, you get the data, cut data, clean the data, pre-processing, etc., ready for your training, and you can create a model. If you're using TensorFlow, you can use tf.Keras together with some Python libraries, NumPy, Matplotlib, etc. And then you train the model and you saved it into a saved model or Keras model format. And then you can deploy it for inference, cloud, web, mobile, IoT, edge devices, etc., etc. So why do we need on-device, put that model on device? Not all the models need to run on device, right? But if we're talking about art and design, and it's really all about the camera, on-device, mobile devices all have these days have pretty good camera, right? And the camera can capture images. So what is TensorFlow Lite? When I was talking about over here, when we deploy to mobile edge devices, we need our model to be small and run fast, right, on the edge devices, the mobile devices. So that's where TensorFlow Lite comes in to help. It's a lot of people, when they think about TF Lite, they think about the TensorFlow Lite formats. Well, it's not just a model format, it's also a framework with a bunch of tools. If you are new to TensorFlow Lite, chances are you've worked with a converter, which converts a saved model or Keras model or .pb model into a .TF-Lite model format. And then you're probably also familiar with the interpreter if you're running applications on, say, an Android app. You will need to use an interpreter to run the inference of your model. And then there's ops and kernels, and then interface of the hardware acceleration, neural network, PI, and edge TPU, and then a bunch of other tools to do quantization, including benchmarking, and also to deploy the models to mobile devices. So just last week, TensorFlow Lite team has announced the first release of TFLite support. And what is TFLite support? And it's this group, a toolkit of various libraries like the Task API, support library, metadata library, CodeGen, custom ops, model maker, and ML model binding, which I'm going to talk about in a little bit. So the support library is for help you with like the pre-process and post-processing if you're implementing your code on, say, mobile. It helps you to avoid writing some boilerplate code. And then the Task API and the ML model binding helps you to implement the models easily on your mobile, in your mobile app. And to support that, the CodeGen and the metadata is under the hood supporting, say, the ML model binding here. And then the model maker is what you can use to train a model easily. So anyway, so there's a whole slew of new tools. Now let's talk about how you go from TF.Keras to TensorFlow Lite to Android. As I already mentioned earlier, for you that you have data and then you train. And when you write TF.Keras model code, you can use the sequential functional API or you can use model subclassing. And the sequential API is the simplest for beginners. Functional API gives you more customization, so choices, and then model subclassing is really if you're a researcher, you are implementing papers and you will be using model subclassing. So if you're familiar with PyTorch, then the functional API and the model subclassing is what PyTorch has, like quite equivalent. Then you convert it to TF-Lite. When you do the conversion, you can either convert with Python code or command line. And then you can, if you run it on Android, these steps is really tedious. You have to manually create an access folder, then update your build.gradle, capture an input image with the camera, or maybe select the image from your gallery and then do the pre-processing and then classify the model, do the post-processing, display result. Anyway, lots of steps. The reason why I'm going through these is to show you how, like, even if you implement the MNIST on very simple MNIST model on Android, it's a lot of steps, right? If you do it manually, but we have tools to help you. So what are some of the things that can help you make these things easier, right? If you're not familiar with Keras, you don't know how to write Python code, you can use a teachable machine. In teachable machine, where it's like a web interface, you can just upload your images and then it can train the model for you. And I think they can handle probably text classification as well. And then there's model maker where you do need to write the Python code, but you don't have to do the pre-processing, post-processing. It's just like 3 lines of code. As long as you have these multiple folders of images, you can make a model and run that in Colab, turn on GPU mode, and then you can make a model. And then if you don't want to train your own models, you can use MLKit or AutoML Vision. It's kind of like the teachable machine as well, like where it's web interface, so you can train them. And then for the conversion, you use the converter, and then you can use the optimization toolkit to optimize it and make it smaller or faster. And you can use the benchmarking tool to benchmark. And then when you deploy, as I mentioned earlier, you can use ML model binding or task API to make it easier. Like, for example, all of these steps over here, you don't have to do all the steps. You can just use the ML model binding. Like in Enter Studio, it's basically where you can just click the UI to find your model and then import it. And then with the task API, it's just a couple lines of code, really easy to implement. I have also included the People and AI Guidebook by Google here to help you design human-centered AI products. So now I'm going to talk about some Android apps and tutorials by the community and also by the official TensorFlow and TensorFlow Lite team, MLK team. Just some fun examples. Like this one is the MLK digital ink recognition. The main purpose is to be able to recognize handwritten text and drawings. And it has text models recognizing 300 languages. But it also has some really fun non-text models like AutoDraw, Emoji, and Shapes, recognizing shapes. So here I'm including an example where you can just draw a frowny face with tears, and then it will propose this icon for you. And then here's also another example, really fun. I think it just got announced a couple of weeks ago. This is the enhanced super res GAN on Android with TensorFlow Lite. It uses a pre-trained ESR GAN model from TensorFlow Hub, and it converts to, the blog post will teach you how to convert it to TensorFlow Lite model. And it uses dynamic range quantization. The input image is 50 by 50. And a lot of the examples you can find online is either using Java or Kotlin or Flutter. So this one actually using the TensorFlow C API with GPU library and Android NTK. So if that's what you prefer, this is a good example to check out. And I wrote a 2-part tutorial last year on how to use TensorFlow Lite model to make an icon classifier. So this is what I was talking about earlier, the model maker, right? So if you're in a Colab notebook and you can get data from TF.DS, from Kaggle, from the internet, or just photos of images of your own. And in this case, I have 50 classes of icons. And then just a couple lines of code from this library called the model maker. It will handle the data preprocessing and the model training, under the hood transfer learning, and then you can do some model evaluation, and then the model conversion export. It's all already handled. Like a couple lines of code, you have a TF-Lite model already, and the TF-Lite model has metadata, and the code gen support that. So in Android Studio, I could just import this TF-Lite model I created here and easily implement it here. And then you have an Android app with this UI where it can recognize like 50 classes of icon. So I have included the links here for you. You can feel free to check it out. I also encourage you to check out the Google Arts and Cultures app. Inside of the app, they included various links to museums, to different kind of artwork, blog posts, etc., etc. And it also has the style transfer app in there as well, where I mentioned earlier about style transfer, where you have a content image and a style image, right? So you can check that out, how you can transform your photo in the style of an iconic artist. So this is a project that I worked on, really fun. It's called the Selfie to Animate. And I worked on it with another machine learning GD, Sanyak, from India. And this was, I worked on quite a few GAN, implementing GAN on Android project. This was the very first one that I worked on. And there are some limitations, as you can see. The images that generated is not like super clear. And also the images generated on female faces look better than on male faces. And that's because the training data had some sort of bias and trained it only on the female faces and didn't work so well on other faces, particular female Asian faces. So, this is a classic example of machine learning bias, model bias. And then later on, I worked on another one called the Cartoonizer. And this one we use it's a different model called the white box CartoonGAN. And it's much better, runs faster, and it doesn't just work on selfies. It can work on cats pictures or, a natural scene, maybe flowers. And it works on any kind of faces. It doesn't have to be just like female faces or Asian female faces. It works really well on all kinds of faces. And then another one is segmentation plus style transfer. This one we apply the style transfer. We apply the segmentation first, and then segment on the foreground and background. Then apply the style transfer to just the background. And this is a very interesting use case because sometimes when you apply just the style transfer to like a human face or human portrait, it may not look so great, but if you apply to just the background, it has a really artistic feel, but then you preserve the foreground of the, the human pose and the human face. And another interesting thing about this project is like it has two models. One is the segmentation model, another one is the style transfer model. So it's also interesting to check out this application to see how we chain the model together, because this works on a mobile phone. It works pretty well, perf-wise. You don't feel much lag, or you don't have to wait for the processing to be done. So this is another thing I want to introduce to you. This is called end-to-end TensorFlow Lite tutorials. It's a initiative that's supported by machine learning GDEs and the TensorFlow Lite community in general, where we contribute to write a lot of different sample apps using TensorFlow Lite. And not only we write the code, we also write the end-to-end tutorials. So feel free to check it out. And then here's the awesome TensorFlow Lite. This is the repo I put together last year. It has a curated list of models, apps, tutorials, and learning resources, and has a lot of support of the MLGDs, the Android community, TensorFlow Lite team, and the TensorFlow Lite community. So check it out. This is, there's this official TensorFlow Lite documentation on TensorFlow.org, right? And they also have their examples. But then here I included both the official examples as well as the community examples. A lot of great examples. So that's it for my talk. And if you are interested in learning more about deep learning, TensorFlow, and on-device machine learning, just follow me on Twitter and Medium and GitHub. So I saw some comments and things popping up. Now I'm ready to take a few questions.
Yeah, lovely. I would like to first thank you for everyone for coming today. And while you're typing into your questions into the channel, or you can ask them, of course, if you unmute yourself. Mrs. Margaret, I want to say thank you, especially for such a wonderful presentation. And you can follow her on any of the platform that's on the slide right now. So if anyone has any questions, now is the time to ask.
Okay, so there is a question. Is only CNN model explainable as machine as ML or DL model. I don't quite understand the question. Is the question that only CNN models explainable, like in comparison to what other models like?
Sorry, let me explain that. So I've heard some machine learning model are black box, but for now we have some tools can visualize the neurons for CNN neurons. So I'm curious if only the CNN or computer vision neuron is explainable, or other machine learning model also explainable.
Actually, when we talk about models as black boxes, we are actually referring to deep learning models, because when we use deep learning, we are not doing the manual feature engineering like the traditional ML models. So the training actually trying to figure out these features if you were trying to detect the cat, right? And so, yeah, you can definitely visualize the neurons like throughout the training process. And also GCP, right now it's also working on explainable AI, and it has some functionality where it will show you some of the regions in the images, aside from visualizing the neurons throughout the training process, but also show some of the regions where the model is actually detecting and how the model is making its decision in its classification. So I think the explainable AI for deep learning is still quite early phase. And when we talk about explainable AI, I mean, in this case, I'm talking about art and design, I'm talking about images, right? But when you think of machine learning models, whether it's deep learning or not, when you think about other models, like, for example, deciding on a loan application, whether to reject this application or approve this application, like, how is the decision made? What are some of the metrics or the features that the model is using to make that decision? It's quite important. Okay, who is owning the copyright of generated image? Can we use images with copyright to train a model? So I think copyright has different levels of copyright. Let me just go back to here, and let me just go to GitHub. So I'm gonna just show you, this is my repo with some of the data right here. If you were, typically if images has copyright saying you're not allowed to use, reproduce, or do anything, like really strict, I don't think you can use that for machine learning training, because you cannot like copy it or anything. But the Ontago, if you look over here, like these images, they are free for you to use, and it's already prepared for you for training and validation data set, which is quite nice, right? And then if you look at this one, like at the British Museum, and then you'll see that they said 1.9 million images available for free, right? And then you look at the license, Creative Commons 4.0 license, or whatever the license is, you will read what the license says, what you're allowed to and not allowed to. Sometimes you can copy it and you can do stuff with it. You can edit it yourself, but as long as you're not selling it or like post it as your work. But there are some artwork out there, you're just free to do whatever you want to. Like this one, let's see. Yeah, this one is also free. And then also this one, I want to show you the Metropolitan Museum of Art. Click on this open access artwork. All of these, like you can do whatever you want. Right? These are all free. So I hope that answers your question. It depends on the copyright, what type of license they're giving you. So be careful. Like when I present this, all of these, my slide, all the things and different things, these things, either, like this Van Gogh painting, etc. I made sure either I purchased it, like this fine, similar fashion, I actually purchased it and I'm not selling it. I'm just using it in my presentation, which is okay, right? And then this Van Gogh picture is free for me to use. Any other questions? So there was a common thing. I thought background changing feature used this model. Background changing feature uses. Yeah, I mean, in general, like we apply segmentation and then apply the style transfer. This is a new example though. This one is a new one. I wanna just show you. So it's actually this one, the background style lighter. So this one is, we had this in the, on the Medium as well. So where you can read about the details of the project background and then how to convert the model and how to implement on Android. Are there any other questions for me?
I'm thinking because video and film is just a set of images. So can we use the cartoon transfer model to transfer these for produce like cartoon video? Can we do that?
I think so, because your voice was clipping out, but you might have already said this. Video is just a set of frames of images. You can absolutely, in fact, I don't have the link here. I'll share with you later on. But when I did the selfie to anime here, I should probably include that link here. Somebody in Japan actually took the exact same model and applied it to a video. Because our example is on, pictures, right? Take an image, a picture here, and then change it to anime. So somebody promptly implemented it to video like a week later or within a couple of days.
And then I think Milan sent a question in the chat. As a web developer, she's seeing a trend toward progressive web apps and trusted web apps, which allow you to add a website to your phone screen, and with TWAs, even list your web app to the Play Store. And that means you only have to choose one code base. She mainly used Angular. This would mean that she could use TensorFlow with Lite or TensorFlow Lite. So she's curious about your opinion towards TWAs.
That is a very good question. I'm not familiar with web development. I mean, my knowledge about PWA is as far as running an event for GTG Seattle on PWA, right? So I don't know the details there. But I know that TensorFlow JS has a lot of cool examples for web developer. So if you're a web developer, JavaScript, right? That's Angular and JavaScript. That's what you are most familiar with. I highly recommend you check out TensorFlow JS. Today, my talk was mostly on TensorFlow Lite. I think maybe in the future, when I give my talk about AI for R&D design, I'm probably going to include some examples with TensorFlow JS. In fact, they have, I look at their examples that they come up with and applications. I feel like some of the stuff we haven't implemented on Android or iOS yet. They're already implemented with TFJS.
Thank you.
Yeah, and then let me show you a person you definitely should follow. Let me see if this is the right one. Follow Jason Mays. He's the senior developer advocate for TFJS. He has a lot of cool examples and webcasts on using TFJS to make cool applications.
Yeah, so if there are no further questions, I'm going to stop the screen recording, and thank you again for everyone for coming to the event today. Thank you, Mrs. Margaret. I hope everyone have a good rest of your day, and follow our, keep tuning in and for our Discord channel for further information, and we'll see you later.
Great, thank you everyone. I also joined the Discord channel, so if you have any questions, feel free to ping me there.
Thank you.
Thank you.